Hey guys, welcome to day 2 of Intellipaat's Python week. Last session we learned about Python installation and introduction. Today we'll learn about Python variables and operators. So before moving on with the session, please subscribe to our channel.
And also hit the bell icon for the upcoming updates from our channel. And also if you enjoy our content, you can leave a like.
So in this Python certification series, we'll learn about Python variable and Python token. Let's discuss them one by one. So our first topic is Python variable. How do you think the values assign? Well, for assigning the values, there are two different methods. First is assigning single value to a variable, and the next is assigning multiple values to a variable. So let's start with assigning single value to a variable. You know what? Unlike Java or C++, you don't have to add any data type for a variable. Just specify the name of the variable, for example, a equal 10. So depending on your data, Python will automatically detect the data type of your variable, which in this case is integer. Alright, let's see another example. Suppose we have a name as Victor. So Python will automatically detect that this name variable is of data type string, since it stored the string value. Alright, next we have salary as 2000.23. So since 2000.23 is nothing but a floating type, so automatically Python will detect that salary is of a data type float. You don't have to specify a data type to a variable. Alright, let me just show you this example in our Jupyter notebook. For example, I need to store an integer value. So I'll name a variable like a equal 10. 10 is integer and I'm not specifying any data type for it, right? Hit enter. Since no error is appearing, so I guess it's correct. But what if I just write int a equal 10? So as you can see, it gave me an invalid syntax. So you cannot use any data type before a variable. Alright. Next, what if I want to store a string variable? Just like name equal John. Alright. Hit enter. Similarly, for a floating data type, salary or any variable name equal 2023.234. Alright. It's as simple as that. Alright. So now that you have learned how you can assign a value to a variable, let's see how you can have multiple assignment to a same variable. Alright. So let's suppose you are assigning three variables as a equal 10, b equal 10, and again c equals 10. So here we have three variables, and what you have to do, you have to assign the same value to all of them. So instead of assigning value one by one, what you can just write, you can just write a equal b equal c equal 10. Alright, and it will be executed without any error. Fine. Now this was simple. Now what if you have to assign different value to each variable? For example, I have a variable as x equal 20, y equal 30, and z equal 40. So in this case, what you can do for multiple assignment, you can just write x comma y comma z equal 20 comma 30 comma 40. It's as simple as that. Now let me just print any of the two variables and check if we are correct or not. So let's print y and let's print a. So yeah. So we got the output as 30 and 10. Y equal 30 and a equal 10. Even if you want, you can just check it by updating the value like a equal b equal c equal 20. And this is, make it something else like 40 and 50. And now print the value of y and a. So you'll get the value as 40 and 20. Alright. So this was about the assigning single value to a variable. We also learned about assigning multiple values to a variable. A equal b equal c equal 10, and this example we already did, right? And we got the output as 2010. Fine. So now that you know how you can assign value to a variable, so let's move ahead and start our discussion with some basics of Python. So I'll start with Python token. So what exactly is this Python token? Well, Python token is the smallest meaningful component, or it is a very basic component of the source code. The characters are categorized as one of the 4 class of tokens that describe their functions. It can be a keyword, it can be a literal, it can be an identifier, or it can be an operator. Fine. So let's discuss them one by one, starting with keyword. So what are these keywords? Well, these keywords are some sort of reserve words which are designed for a specific purpose. You cannot use a keyword as a variable name or an identifier name. Some of the keywords in Python include for, if, del, break, continue, true, false, etc. You cannot use them as your variable. These words in Python have a specific purpose and have a specific meaning to it. Alright, let's move ahead. Next is the identifier. Well, it is the name which you give to your variable or to your function or to your class. For example, if you are defining a variable as a equal 10, then the word a or the variable a is defining the identifier. Alright. Well, before you start naming your variables or methods or class, you must know that there are certain set of rules or guidelines for naming an identifier. Let's see them one by one. So the first one is no character except the underscore can be used as an identifier. So what does that mean? Let's see. So you cannot have a variable name as 80 at the rate 123 equal something, any value. You cannot have a variable name like this. It will throw you an error. Alright. Or you cannot even have a variable like 80.we equal 20. Even this will throw you an error. Alright. But instead of it, if you write 80 underscore we, this would be perfectly fine. Alright. Next is keyword should not be used as an identifier name. This I told you earlier also, right? It's like if you are mentioning some keywords like if equal 10, obviously this will throw you an error. Or you're writing while equal 10, then this will give you an error. You cannot use any keyword as a name of an identifier. That is a name of a variable, a class, object, or a function. Alright. Next is Python is case sensitive. That is var with capital V and var with small v are two different identifiers. Let me show you this. Suppose I mentioned a equal 20 and capital A equal 10. So what do you think the value should be if I print A? Would it be updated to 10 or would it be same as 20? Well, let's see. So the output is 20. So it means that small a or the a in smaller case and a in uppercase both are treated differently in Python. Print capital A. Alright.
Just a quick info, guys. Test your knowledge of Python by answering this question. All keywords in Python are in A, lowercase, B, uppercase, C, both uppercase and lowercase, D, none of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So let's move ahead. Next and the last one is first character of an identifier can be a character underscore but not a digit. Well, what does this mean? 1 to 80 equal 10. This is wrong. 1 to or 41 at the rate RAC equal something. Even this is wrong. But what you can do instead, you just specify underscore before this. Underscore 41 RAC without the at the rate part, as no special character other than underscore is allowed, equal 10. So this thing would be accepted without any error. Fine. So this was all about the identifiers. Next comes the literals. Well, literals are the constant used in Python. Or you can say that literals are the data given in a variable or a constant. Basically, there are 4 different types of literals: string literals, numeric literals, Boolean literal, and special literal. Let's have a look at them one by one. Starting with string literals.
Just a quick info, guys. Intellipaat provides online Python certification training mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
Well, you can create a string literal just by enclosing a text within the code. Both single and double quotes are allowed in a string literal. For example, you can have a variable as name1 equal double quotes John, and you can even have a variable as name2 equal within single quote John, or maybe James. Both are correct. You're not getting any error, right? So since you are not getting any error in the output, so it verifies that you can use both the single and double quotes in string literal. Okay, now what if you have multiple line input? So how will you print that? Let's see, for a multiple line input, multi-line equal. So all you need to do is mention 3 single quotes, just 3, alright? And after that, start writing like string 1, enter different line, string 2, line 3, string 3, and so on. Alright, and again you have to end it using 3 quotes. Fine, execute it. You won't get any error. And if you print the multi-line, you'll get the output as str1, str2, str3 in 3 different lines. Alright, let's get back to our tutorial. So what was our input? Name1 equal John, name2 equal James, print name1, name2, and we got the output. We have to discuss this. We have a multi-line thing within triple quotes. You had a multi-line thing in which you needed the output in 3 different lines. So yeah, you got it using 3 quotes. Alright, fine. So this was about the string literal. Later in this session, we'll see what are the various other functions you can perform on the string literal using some of the Python's existing libraries. For now, let's move ahead and let me give you an overview of numeric literal. So what are these numeric literals? A numeric literal is a character string whose characters are selected from the digits 0 to 9. It consists of a sign character. It can be either positive or negative, or it can even contain a decimal point. Well, if the literal contains no decimal point, then it means that it's an integer. If your number is too long and we add capital L or small l at the end of the number, it makes it a long number. Or if the literal contains a decimal point, it becomes a float. But yes, remember that you can only use one decimal point in a number. Have you ever seen a number with more than one decimal point? Never, right? Well, just for the FYI, I'm not talking about the IP. Alright. By the way, in Python, the value of an integer is not restricted by the number of bits. It can expand to the limit of the available memory, and since the value of the integer depends on the available memory, so no special arrangement was made in Python for storing large number. So any doubt up till this portion? Well, if you have, please add it in the comment section below. Alright. So moving on ahead, next we have is the Boolean literal. Well, these Boolean literal have just 2 values, either true or false. Well, remember that both these true and false are also a keyword. So you cannot use them as an identifier. They are generally used when we are dealing with some condition whose outcome is either true or false. Alright. So this was about the Boolean literal. Next we have is the special literal. Well, Python has just one special literal as none, which is used to specify the field that is not created. Well, if you are from a programming background or you just have a basic knowledge about C, C++ or Java, I think you must have heard about the keyword null, right? Well, if yes, then this null is nothing but the equivalent of null keyword in C, C++ or Java. Alright, so I hope that you guys have understood about literal. Well, there are many cases where you can use none. Let's see an example. Alright, nothing needs to be explained in this. So what are these operators? Well, these are some specific character which have a specific task to perform. And based on the function and the task, the operators are further segregated into 7 different types of operators: arithmetic operator, assignment operator, comparison operator, logical operator, bitwise, identity, and membership operator. Fine. So let me discuss them one by one. So starting with arithmetic operator. Well, arithmetic operators are the one which is used to perform some arithmetic calculation. So what it does, it takes two operand to perform operation on them. For example, 2 plus 3. So here 2 and 3 are operand, and the character plus over here is nothing but arithmetic operator. Alright. So there are other arithmetic operators too, like plus, minus, multiplication, division, mod. All these characters are a part of arithmetic operator. Let me just show you one more example. Like 1 plus 2. So here 1 and 2 are the operand, and plus here is a arithmetic operator. 1 minus 2. Again minus is a arithmetic operator. 2 mod 1. Mod is what? Arithmetic operator. Alright, let's move ahead. Next we have is the assignment operator. Well, this assignment operator is used to assign a value to a variable. The character which comes under this operator are equal to, plus equal to, minus equal to, multiplication equal to, and etc. For example, you declare a variable as var equal 10. So this equal to is your assignment operator and is used to assign value to a variable. Let's get back to our Jupyter notebook and learn more about it. So, for example, I'm defining a variable var equal 10. So this equal to is nothing but a assignment operator. Var plus equal 10, again an assignment operator. But what does this mean? So what does this mean? Well, it means that var equal var plus 10. Alright. So if you print the value of var, what do you think the output should be? Well, you'll get the output as 20, since the value of var is already 10. So 10 plus 10, it's 20. So the updated value of var is 20. Similarly, you can perform var minus equal to 10 and again get your value printed. So again, the updated value of var would be 20 minus 10, 10. So this plus equal to or minus equal to, it is generally named as a shorthand, which means add or subtract and assign value to self. Alright. Same example is mentioned over here, like a equal 10, a multiply equal to 10. So it means that a equal 10 into 10. When you print a, you'll get the output as 100. Alright. So next we have is comparison operator. Well, it is used to compare two values and it returns true or false as the output. Alright. The operators which are a part of it are less than, greater than, less than equal to, greater than equal to, or not equal to. For example, let's see what example we have up here. A equal 10, b equal 20. A is greater than b. Obviously 10 is not greater than 20, right? So it is giving me false as the output. Alright, fine. So let's move ahead. Next is the logical operator. Well, these logical operators are used to perform some logical calculation. And the operators or the keywords which are a part of it are and, or, and not. For example, we have a equal 10 is less than 10 and 2 is greater than minus 1. Then print a. So you are getting output as false. Okay, let's jump back to our Jupyter notebook and see why we are getting the output as false.
Just a quick info, guys. Test your knowledge of Python by answering this question. All keywords in Python are in A. Lowercase, B. Uppercase, C. Both uppercase and lowercase, D. None of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So you had a equal 10 is less than 10 and 2 is greater than minus 1. So if you see, we have two comparison operator up here. So what is the value of 10 less than 10? Since it is a comparison operator, so it will give me a false, right? 10 is not less than 10. And 2 is greater than minus 1. This is true. So you can summarize this as false and true. Alright. So since it's false and true, therefore it equals to false. Well, how? Well, do you remember the binary calculation that you have learned in your college? It's like 1.1 equal 1 or 1.0 equal 0 or 1 and 1 equal 1 or 1 and 0 is 0. So consider true as 1 and false as 0. So false and true is false. Alright, that's why you got the result as false. Now if you print the value of A.
Just a quick info, guys. Intellipaat provides online Python certification training mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
You'll get the output as false. Alright, so next we have is the bitwise operator. So this operator is used to perform the bitwise calculation. This operator includes and, or, left shift, right shift, not. Alright, so let's see their use one by one. Let's see the example what we have up here. So we have 7 or 5, the output is 7. 7 and 5, the output is 5. So how do you think we are getting this output? Let's see the calculation. So how it is calculated. So if you convert 7 into its binary form, it's 111. And if you convert 5 into its binary form, it's 101. Now if you are performing OR, so basically you are performing a binary addition on it. And if you are performing an AND, you are performing a binary multiplication on it. Alright, so let's see. So if you are performing a binary addition on it, so 1 plus 1 is 1. 1 plus 0 is again 1. And again 1 plus 1 is 1. So that's why you are getting the OR of 7 and 5 as 7. Even you can verify this using the calculator. Open a calculator. Yeah, it's a programmer calculator. So 7 or 5. So you'll get the output as 7. That's correct. Fine. Next operator that we have got up here is tilde operator or the not operator. Well, this operator is used to perform a not operation. So what is not of 7? What is not of 7? It's minus 8, right? How it is minus 8? Let me just show you using a notepad. Let's open notepad. Alright. So 7 in its binary form with 4 bits, what it is? 0, 1, 1, 1. Alright, if you perform a not of 7, that is not of 7, what you will get? All the bits would be switched. Like 0 would be converted to 1, again 1 to 0, again 1 to 0. So you'll get 1000 and automatically a negative sign would be added at the beginning. So you'll get minus 1000 in binary form, which you convert into decimal, you'll get it as minus of 8. Alright, that's why the output of not of 7 is minus 8. Fine. Next is the left shift and right shift operator. Let's see what is the output first. For example, I'm trying for a right shift. Then 10 right shift 2. What is the output? It's 2. Let's see how we got the output as 2. Open our notepad. Let's remove this. So 10 in its binary form, what it is? It's 1010. Alright. Well, when you're performing the right shift, you're telling the interpreter that you want to shift your bits toward right. And how many bits you want to shift is basically 2. Since you have mentioned 10 right shift 2. Alright. So 1010 shifted 2 bits to the right. 00 and remove 10 from the end. Alright. So this is how you are shifting 2 bits towards the right. So you got the result as 0010. So now if you convert this into decimal form, you'll get the output as 2. Fine. So it's like you're trying to push 2 bits from the left towards the right. Is it clear? Alright, fine. Let's move ahead. Next we have is 10 left shift 2. What is the output? It's 40. Let's see how we got that output. Again, 10 in its binary form is 1010. So when you're performing a left shift, it's like pushing the bits from right towards the left. So 10 left shift 2 is like 1010 and you're adding 2 bits in the end, since you are shifting 2 bits to the left. So you are getting 101000. So let's convert this into its decimal form. So 101000 in its decimal form is what? 40. So that is why you're getting the result as 40. So there's a shortcut trick. Well, the shortcut trick is that just add zeros equal to the number of bits that you want to shift towards the left. Alright. For example, I want to perform 10 left shift 3. So my output should be 101 000 and one more 0. Alright. Since I'm moving 3 zeros. Alright. Since I'm moving 3 zeros towards the left. So let's convert it. So it's 80. So you're getting the output as 80. Let's verify it again. Well, if you perform 10 left shift 3, you'll get the output as 80. Fine. Well, I hope the bitwise operator is clear to you guys. Well, in case you have slightest doubt, please add your doubt to the comment section below and we'll try to reply them at the earliest. For now, we can just move ahead to the identity operator. Well, these operators are used to test if two operands shares an identity. The operators which are a part of it are is and is not. These are basically two keywords. Alright? For example, what we have up here, x equal 10, x is 10, it's true. Or x equal 10, x is not 10, it's false. Alright? It is just used to test if the operand shares an identity or not. Alright? So next and the final operator in Python is the membership operator. Well, this operator is used to test whether a value is a member of a sequence or not. The sequence may be a list, it can be a string, or it can be a tuple. I know some of you guys might be thinking, what is this list or what is this tuple? And guys, I'd say that just be patient. I'll teach you about them in detail during this session. For now, you can just understand that this list is almost same as array, which you had already studied in C, C++ or Java. It's almost same as that. Alright? And this membership operator, it is used when you want to check if a certain element is present in a list or not. So let's see what are the operators which are a part of it. So well, we have in and not in keywords which are a part of this membership operator. Alright, let's see an example. So what's the example up here? So we have defined a list, or you can say we have defined an array, which consists of dog, cat and wolf. So we are checking for lion and pets. Since pet is the name of a list or an array, you can say. So we are searching for lion and pet. So since there is no lion in it, so the result is false. Next, what we are doing, we are seeing for wolf and pets. So yeah, wolf is present in pet. So we are getting output as true. Alright.
Just a quick info, guys. Intellipaat provides online Python certification training mentored by industry experts, the course link of which is given in the description below.
Okay guys, we've come to the end of this session. I hope this session was helpful and informative for you. If you have any queries, leave a comment down below.
Thanks for watching.